Okay, good morning. Okay,
Good morning, sir.
Good morning, sir.
okay, okay, good morning. Till now, we were discussing about various types of machining operations, and we have seen the basic difference between the conventional practices and advanced machining operations. And in the last class, we were discussing about the high velocity forming practices, and where we have seen basically two classifications, mainly high velocity forming by explosive forming, where an explosive is used, and in latter case we have seen a electrospark forming, where the resource or the source of the input or the input source is a spark. So we have seen many kind of processes. So these are all in a macro level. That means it is a the workpiece or the deformation is happening, whether it is a deformation material addition process or material removal process. These all process occur in a macro level, or in a somewhat we can see with our naked eye. That means it is in a huge manner. So now in the present scenario, what we can see is everything is miniaturizing. So everything is has got miniaturized. We can see the size of the components are becoming small and small. So in order to make it small, what we need is we have to uh, miniaturize the each components of the system. So say the case of a watch, we can see in a watch there are many components, and for each uh, elements of the components you can see how it is machined. So in the micro level or a small level, nano level, if it is possible, then we will be able to miniaturize the components. So in many cases like electronic equipments and all, in the PCBs and all printed circuit boards, you can see a very small cuts or very small machining is being done. So not only machining but some other material addition process also, like filling of the or any coating, polishing, micro finishing, micro coating, micro drilling, any such machining operations can be done in the micro level and also in nano level. So this is the thing we have seen in micro machining. So in this module, the final module, we will be discussing mainly on the micro machining techniques and also some advanced finishing processes, like we have already studied some process like abrasive jet machining, abrasive water jet machining and all. So these all steps, these all machining processes in a micro level, how it can be done in a micro level or a nano level, that we will be seeing. Okay. And also some other process like magnetorheological abrasive flow finishing, magnetic flow polishing, elastic emission machining, stereolithography, Liga process, etc. etc. There are many machining operations, whether it is using some direct contact or not having a contact, or using some laser equipments and all. So we will see one by one. So first of all, we will see as an introduction what is a micro machining or nano machining. We have already uh, seen this thing in our first module. Anyway, we'll go to the topic, micro machining. So what is a micro machining? This includes all the cutting operations in which a material is removed at the micron level. So what is a micro machining? Micro machining is nothing but A machining operation. Machining means removal, material removal. So in the earlier cases, we have seen the forming operations and all. So that is not, we cannot call it as a machining because the material is not being removed. It is just plastically deformed to the final product. Anyway, in micro machining, by the term machining, we refer to any process where the final product can be machined or made by removing the excess material so that the final product can be obtained. So this particular operation procedure, machining, when done in a micro level, that is a that much small value, then we can call it as a micro machining operation. And you can see the size range. The size range of the micro machining is about 1 to 500 micrometer. So this level or this range of materials removal is being done using certain procedures or certain machining operations, and we call it as micro machining. Now, which all products which are developed using the micro machining, we call it as a micro products. That is the products developed using micro machining. So what is the peculiarity of the micro products? So this can be done, or the micro products can be developed or manufactured by two cases, either by material deposition or by material removal process. So what is a material removal and material deposition? Material deposition or material removal is nothing but the actual machining operation itself. That means the final product or the final component is being made by removing the excess parts or excess uh, bulk which is not required for our end product. So that is a material removal process. Material removal process mainly includes the turning, grinding, slotting, shaping, anything like that where the material is being removed. And material deposition. Deposition means we are adding the material towards the existing workpiece so that additional surface is being built up to form a final contour. So that is a material deposition. For example, by EDM, using EDM process, we have already studied the EDM process. What is that? Electro discharge machining. So in electro discharge machining, we have applied a potential, and using the spark or the heat energy produced, you can melt the material and remove the material from the surface so that holes are produced or the cutting is being done. So there we see the material removal process. If the same process, there is a EDM, if we can reverse the polarity, and you can even able to have the material addition by adding the material, extra material, molten material towards the surface, that you will see in the later cases. Okay, how the material addition process is being done. Anyway, the basic thing is we are applying extra material, extra metal towards the workpiece. That is, we are adding the material. That is the depositing, or we are depositing the material towards the end surface or the end product. That is the material deposition. So these micro products, which all micro products are available, these are being developed or manufactured by either by two of the process, like whether it is a material removal process or a material deposition process. Okay. So these are mainly about the micro machining, and also we can see micro turning. So spacing, drilling, etc., etc. Even thread cutting also we have done, right? So that is familiar to you. Now, micro turning. Micro turning means the turning itself in the micro level. That means the turning operations whose accuracy or the tolerance level, everything occupies in the micro range or nano range. So here in the micro turning, what we use is a solid tool like the conventional processor itself. Similar to conventional turning operation, we use a solid tool. So what is the peculiarity of it? That is, here it is having a high precision, precision and accuracy. What is the difference between the precision and accuracy? Accuracy means nothing. Accuracy means it is the close to the trueness or true value. Suppose we need a shaft of 50 mm diameter. How close we can produce or we can machine up to 50, whether it is 50.00001 or 49.9999, something like that. If it is like that, we can say it is more accurate. If the value goes beyond the limit, then we can say the accuracy is being lost. So that is the accuracy, that is the trueness of the value or closeness to the true value. And precision means nothing but if we want to produce 50, maybe you are able to machine it to 49. But for all the products, like for the first time and the second time, third time, fourth time, for any time you are getting the same value, then we can say your production is a precise. You are producing precisely. So that is the difference between mainly precision and accuracy. Anyway, high precision, and also high accurate machining in the nano level or micro level can be possible in micro turning. So these are about the basic introduction to micro machining. Now we'll see some of the advantages. So these are the key advantages of any micro products. So micro products you have already seen the range is 1 to 500 micrometer size. So these types of products, while using these types of products, what are the main advantages? First of all, increased function. So it is having many functions in the present scenarios. So many its functionality is increased if it we can produce the miniaturized components. Then reduced material requirement. That is a simple concept. That is, if we are having only small amount of products, or if the size of the product is small, means we need only small amount of materials. If the expensive materials are to be used, then if the miniaturization is possible, then it will be economical. So that is the second case, that is reduced material requirement. Third one, reduced power requirement. So due to the miniaturization, we need only a small amount of material, and also the size is small. So when the size is small, we can say the whole system is smaller. So in order to have any movement or anything, or to actuate anything, we need only less power. So the reduced power requirement, less space is needed. That means in order to incorporate these components, micro components, we need only less space, because the total size of the each component is small. So that is the main thing of the miniaturization. And finally, less handling and transportation, etc. Everything is due to the miniaturization. So these are the key advantages of micro products. So first one, increased function, then reduced material requirement, reduced power requirement, less space, and finally less handling and transportation. Okay. So now we'll see the applications. So which are the main application or application areas of micro machining products. So micro machined products we can see nowadays everywhere in every field we need miniaturization for many reasons. In order for either for reducing the wastage, for reducing the cost, reducing the space, etc., or reducing the overall power consumption, everything, weight, and all. So we can see in every field, miniaturization is, if it is possible, then we will move on to that, or we will switch on our technology towards the miniaturization for micro products. So main applications are, first of all, industries. In industries, we can see in any case, if we take any case, we can see miniaturization. In the If we go back to 10 years back, then the product may not be like this as such. Nowadays we can see for every product we can see at least a 10 percentage miniaturization. Next, in the automotive applications, automobiles, and chemical applications, even computer you can see we have the size is being reduced and all. Then medical application mainly you can see artificial uh, implantations done mainly using micro machining or nano machining. So the parts of heart, valve, etc., etc., many things are made possible using the micro machining. Then biotechnology applications, electronic applications, we have seen in many electronic components. In any of the electric components, you can see the application of micro machining. So these are the main applications of the what do you say, the micro machining. So in depth, we can say many products and devices which are fabricated using this, like medical components, micro mold, electronic toolings, MEMS. MEMS is nothing that micro electrical mechanical system. Then fluidic circuits, micro valves, sensors, micro turbine impeller, micro compressor, nozzles for diesel fuel injectors, cooling holes in turbine blades, inkjet printer manufacturing, micro switches, everywhere you can see the application of micro machining. So the micro products, micro components, everything is very important in the current scenario. So in industrial sectors and all, we can see mainly the electronics, optics, medical, biotechnology, everywhere you can see this application of micro machining. Now, what are the methods, or how we can classify the methods of micro machining? Micro machining, we can classify. You can see. So this is the classification. I think you can see this. Is it visible? Okay, so mainly or broadly we can classify this methods of microfabrication or micro machining as three, like material deposition, material removal. That is the main classification: material deposition and material removal. Along with that, other processes are also there, like metal forming and all, where there is no addition or no removal, but just changing the shape. Okay, so metal forming we have already seen. So which all forming processes are there? When it is done in the micro level, then we can call it as micro metal forming and all. So those things comes under the third category. Okay. Okay. So is this visible? ഒരു കോൾ വന്നായിരുന്നു, അത് കട്ടായോ എന്ന് അറിയാനാണ്.
ഇല്ല സാർ.
Okay, 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 okay. Okay, fine. So in material deposition, these are the methods like electrode discharge deposition, EDD, chemical vapor deposition, physical vapor deposition, rapid prototyping, Liga process, electrochemical spark deposition. So these all process comes under the metal deposition. So in metal deposition is nothing but the material is being deposited on the final product or the component, so that a contour is being created over that. And in the latter case, that is the material removal process. It is mainly containing two types of process, that is traditional material removal process and also advanced material removal process. Like the macro level, in the macro level we have seen conventional and non-conventional, or traditional and non-conventional process. In the micro level also we have two material removal process, like traditional and advanced. So that also you will see. These are the traditional process include the micro turning, micro milling, micro drilling, micro grinding. So in the previous case we have seen that is a turning, milling, grinding, etc. Here additional micro is there. That's all. And in the advanced process, here also we are having three classification, like the case of a macro machining, that is mechanical, thermal, and chemical. So whether the input is based on the fact that whether the input is mechanical, if we are using the mechanical means to remove the material, then we can say that is coming under the mechanical portion, that is micro AJM, that is abrasive jet machining. These all we have already seen: micro USM, micro AAW, that is micro abrasive water jet machining, AFM, MAF, etc. These all comes under the mechanical action, that is the material is being removed using mechanical action. So using mechanical action the material is being removed. Then in the thermal case where the thermal energy is being used, various kind of thermal energy using any spark or like that, machining is being conducted, or the main source of material removal is the temperature, rise in temperature. Using rise in temperature, material is being removed. So that includes mainly micro EDM, micro EBM, micro LBM, micro PAM, etc. And in chemical machining or electrochemical machining, where the main source of material removal is the chemical change or chemical reactions. So using any chemical reactions, material is being removed, and the main examples include the ECMM, PCMM, etc. So these are regarding the main of micro machining. Now you go to the first topic. Our first topic, it is the diamond turn machining. So diamond turn machining. So this is one of the micro machining operation or micro turning operation, where from the name itself you will get a clear understanding. That is, the tool, cutting tool is diamond. So we are using the cutting tool as diamond, and how we are using, or how what are the process characteristics, or how it is being done, we will see. So first of all, regarding diamond turn machining, it is a ultra precision and accuracy machine. So this machines or machining operation uses the ultra precision and accuracy machines like lathe, using the single point crystal diamond tool. So in diamond turn machining is nothing but a high or high ultra precision, using the ultra precision and accuracy machines, lathe machines, and using the single point crystal diamond tool, we are turning. So the turning operation using this particular mode is termed as a diamond turn machining. And you can see the single point diamond turning. Single point diamond turning. This is actually one of the main methods used to machine precise or precision or ultra precision optical lenses and mirrors. So in many cases we can see optical lenses, usage of optical lenses and mirrors. So where in that the machining, how it is being created. In many optical, whenever you go to any optic, uh, then you can see many lenses, many type of lenses, uh, and also you can see in many shops various kinds of mirrors and all. So the machining of these particular products are made possible, or it should be made in a manner where it is highly accurate, and also high precision should be there. So these all can be done using a diamond tool machining. And the main peculiarity is that the cutting tool edge of this diamond tool used for the machining operation is ranging from few nanometers to 10 nanometers, tens of nanometers. So in this particular range, the cutting tool edge is being created. And here you can see a fine edge radius. Fine edge radius will be given to the cutting tool, the diamond tool. And this is a hard single crystal material, that is a diamond. And this particular tool is being used for the whole turning process in the diamond turn machining, so that as told earlier, we can be able to machine the precision or ultra precision components like optical lens or mirror, anything. And in this particular process or procedure, we can ensure surface finish and tolerance to the nano scale. That is, nano means even smaller than the micro level. So using the diamond turn machining, we will be able to produce the surface with high quality surface finish and also close tolerance. And why we are using the diamond as a material for tool material? Nothing but because the material or the diamond, it softens only at this particular temperature, that is 1350 degrees Celsius. Only in this particular high temperature, the material is being softened. So unlike another materials or any alloys, if it is softening at a small temperature itself, then while machining, the tool will be blunt. So in this case, wherever we are using the diamond is mainly the hardest material. So the temperature level is given here, that is it softens only at 1350, and also the melting temperature is given as 3027 degrees Celsius. So this makes it possible to machine in a our required manner. And here you can see the cutting edge is sharpened mainly to 20 nanometer. In this particular range you can see the cutting edge, and the tolerance level, close tolerance is being possible to the end product due to the extremely smooth spindle. Extremely smooth spindles are there in the machine for diamond turn machining. So due to that, we will be able to have a close tolerance, and also precise and accurate positioning is being possible due to the extremely smooth spindle. And here vacuum chucks are mainly used for the work holding, and hydrodynamic bearing type of bearing used is hydrodynamic for the table movement and all. So these are mainly about the diamond turn machining. So regarding the material removal mechanism and all, we'll be discussing on the next class. So these are about our today's topic. So today we have seen what is a micro machining, what are the classifications, and one among the process, that is diamond turn machining. So